In this video, I will show you how to write the equation of a line in slope-intercept form when you're given the picture of the line. So you're given the graph. Now what we need is this format, y equals mx plus b. And the b is the y-intercept of your equation. And so I can see that y-intercept very clearly here. That point is -6. Now what I need to do is find the slope of my line. So I'm going to look for my slope by going up and over, and tracking what my up and over movement is. Slope is calculated by rise over run. And in this picture, I'm going up 1 and right 1, which will be 1 over 1 for my slope, which is 1. Now I don't really need to write the 1 for my function because 1x, you don't need to say the coefficient of 1. So y equals an x minus 6 would be the perfect way to write that equation. Now in this picture here, I see that we have a vertical line. And a vertical line, I have a phrase to kind of help me with that. Hoi vux. And vertical lines, the vux of this phrase, this means vertical lines have undefined slope and they are the equation x equals to a number. And I actually showed that in a previous video. So hoi vux, hoi is horizontal lines, have 0 slope, and their equations are y equal to a number. But we have a vertical line in this picture, which I know has undefined slope, and so it is not going to have y equals mx plus b format. It has x equal to a number format. And so for this function, all I need to do is find what x value this number has. So this is 0, and this is 5, and this is 1 before that, which would be the number 4. So slope-intercept format doesn't technically work for a vertical line, but this is the format of how you would write that line. Now the last picture over here, I can write it in the phrase y equals mx plus b format, and I can tell my b here is up at +2, and so I know this is going to be +2 because that's where it crosses my y-axis. Now what I want to do as easily as I can, find another point on this graph, and it looks like there is a point over here at 5, 0. So we're going to go and count our rise over run for our slope. Well, in this one, it's going down 2, and then to the right 5. And that would be my slope for my function. This picture here is going to have the same format, y equals mx plus b. And what I'm going to start with is trying to identify the y-intercept, the b of my function. So I'm going to count up 1, 2, 3. So my function will have a +3. And now as best as I can, I want to see if I can find another point on the line and see if that remains true. It looks like this point 1, 5 is a point on the graph, so let's see if that pattern still exists. So we went up 2, right 1, up 2, right 1, up 2, right 1. It looks like that is the pattern. So my rise over run was up 2 and right 1, so that fraction would be 2 for my slope. This function here is a horizontal line. And horizontal lines are y equal to a number. And I have a phrase that kind of helps me remember that. Hoi vux. So I know this is a horizontal line that's going to be y equal to a number. All I need to do is count and see what that number is. So from 0, it's going down 3. So y is equal to -3 would be the function of this line. Now my last one over here, y is equal to my mx plus b, because we do have a straight line going down. I know my slope's going to be negative because this is going down. So let's see if I can track and see as best I can where this slope is going. So I definitely know that the y-intercept is 0. So I'm just going to have a negative slope and then +0, but I don't need to write +0 in my function. So I'm going to see if I can count and go down. it looks like this would be the best point on the graph. So it went down 1, 2 over 1, 2, 3, 4. I'm just going to double check that that worked out right. Down 2 over 1, 2, 3, 4. It does look like down 2 and over 4 would work for the slope of this graph, or up 2 and left 4. That checks out. So I'm going to reduce this fraction because I can to -1/2. And I don't need to say +0 in my function, so I would just leave it as y equals 1/2 x.